Next, we have Harry coming from a beautiful island. Is it an exotic one, Harry?
Hi, good afternoon, everyone. Yes, from an island indeed.
Tell us a little bit about this, please.
Yes, I'm from the Netherlands, as you might hear from my accent. And as you know, the Netherlands share a series of islands. We have Germany and Denmark, and I live on the far western of those islands, actually.
Oh, that's great. Good. How's the weather right now?
Yes, I wish I could tell you all about sunshine and being on the beach, but unfortunately, it's been really Dutch weather, so rain all week, unfortunately.
I understand. Okay, so I'll let you introduce yourself. I also know that you're part of the Microsoft Valuable Professionals program and recognition. And then I'll just, pass the token to you and let you take over the floor.
All right, thank you. Let me share my screen and let's see how this works. There we go. So I hope everybody is now receiving my screen. Yeah. So welcome everyone. In the next, I think 45 minutes or so, I'm going to be talking to you about infrastructure as code using the Azure Resource Manager. But before we start, let me do a very, very short introduction of myself. My name is Henry Been. I'm a DevOps and Azure wannabe from the Netherlands, living on an island indeed. I will share my contact details after the presentation as well. And if you want to talk to me later on, you have some questions or remarks, feel free to reach out if you want to. And I'm just going to move on because I don't think you're interested in me, but I just want to point out one very small thing, and that is that I've very recently released a book. I've written it together with Mike van der Graag, also a Dutch DevOps enthusiast. And normally at a conference, you get like a few copies, you know, to hand out to the person that asks the most interesting question. But that's not going to be happening today, unfortunately. So instead, my publisher gave me a discount code that can get you a 20% off on the book. So if you're interested in learning about implementing Azure DevOps solutions using Azure DevOps and Azure, you can buy this book now with 20% discount. And the book will take you all the way from continuous integration to monitoring your solutions in production. The code is valid for 7 days only, so it's really just for the attendees of this conference. Moving on, the main goal for me today is to try and convince you that when you are working in Azure, and you probably are familiar with this portal, is that you do not need this portal, that we will do no more clicky click in this portal to get our resources. The purpose of today is to teach you how to use Azure without touching that portal and make sure that you enjoy it. And before I dive into how we do that, let's talk a little bit about why I think that's a good idea for you. Well, I don't think you're going to make tons of money, but I think there is a valid business case for moving to infrastructure as code. And I want to share that with you. So there are a number of things that you can get out of it. And the first one is that you will have no more configuration drift. As you know, configuration drift is the differences that over time slowly get introduced between your test environment, your acceptance environment, and your production environment. I think we all know from experience that once you've been working with a set of servers in production for a couple of years, that they will in no way resemble your test environments, and that this will lead to more and more problems over time. So infrastructure as code can help you deal with the problem and remove it completely. Another big advantage of writing your infrastructure in code is that it allows you to very quickly create an environment whenever you need one. Do you need a test environment? Just spin one up. Do you not need it anymore? Just spin it down, remove it, throw it away. And finally, since you can very quickly create them and throw them away, you have a process that is very repeatable. So if you want to create more servers in production that are precisely the same as the ones that you already have, you can be guaranteed that if you repeat the process, you will get the same outcomes. Another advantage of creating your infrastructure as code on the left, instead of clicking it together in the portal, is that all the changes that you make to your infrastructure are reviewable by your peers, by your colleagues. They can see the changes you intend to make You can even just propose them in a pull request, have the remainder of the team vote on the change, and then only when everyone agrees, make the change go to the test environment, then to acceptance, and then to production. And even formal change management, things like the 4 Eyes principle and sign-offs can be done much easier when you're working with your infrastructure as code instead of doing the clicky click in the portal. And in particular, this thing makes that infrastructure as code really neatly integrates with all that we know about continuous deployment. So if you are already continuously deploying your code directly from your source control repositories through a pipeline into production, infrastructure as code can really complement that to extend that practice also to the infrastructure that your code runs on. In essence, it facilitates a change in the way we think about our infrastructure. In the past, we used to, cuddle our infrastructure. They were our pets. This is my server. I give it a name. I'm going to call it Mars. And you get your own server. And you call it Venus. And then we have a production environment that is somewhere that we can not even see. It is owned by the sysadmin, and it's his, and it is his little pet. And we can't touch it. Infrastructure as code allows us to treat our servers or application hosts as cattle. We bring them up, we use them, and then when we don't need them, we slaughter them, we throw them away. It sounds a bit harsh, but if you hear somebody talking about from pets moving to cattle, this is what they mean. And this facilitates a thing that we call immutable infrastructure. It's not really the topic of this talk, but I want to very quickly show this, as this really shows the value of infrastructure as code. And it also neatly completes one of the demos that I'm going to give later on. Now, let's assume I have an application that has users, it has a load balancer, and behind that load balancer, I have 3 application hosts that run my application. Can be app services, can be virtual machines, can be Kubernetes stuff, whatever. I don't know anything about containers, just 3 application hosts. Now, when we're practicing infrastructure as code, remember that we have our infrastructure definition as code, and we can, with one push of the button, create a complete new set of infrastructure. Let's call them our future application hosts, completely not connected to the environment that our users are currently using. And on those servers, we can now deploy our code. And once we have it there, let's test it, like really, really test it. Make sure that it does everything that we need our production code to do. And once we are done with those tests, and only after we have done with those tests, we run a script that slowly updates our load balancer to gradually move a small percentage of our users' traffic to the new application host with the new version of our application. And over time, slowly, we send more traffic to the new application hosts until there is no more traffic going to the old application hosts. Now, what do we do with these old hosts? We just kill them off. Maybe we wait a day to make sure that the new stuff is working properly, but then we just throw them away. And if we flip the image, we're back where we started at and we're set up for a new cycle. Now, the big benefit of this is that we can make our application hosts read-only after the deployment of our code. If you recycle them every day, we don't have advanced persistent threats anymore. There are a lot of benefits associated with immutable infrastructure. And infrastructure as code is one of the prerequisites for practicing immutable infrastructure. And going back to these 4 operations that I just showed on the right, if I reorder them in this way, it's fairly easy to see that this is actually kind of a deployment pipeline as soon as we automate it. And that is why the deployment, the creation of infrastructure at the start of a pipeline and the destruction of old infrastructure at the end of a pipeline makes a lot of sense. And this is where infrastructure as code really interacts with continuous deployment. So I hope you're kind of convinced that infrastructure as code is a good idea, and you want to explore with me together how we can do that in Azure. And to do that, we first need to learn a little bit about a particular part of Azure, which is the Azure Resource Manager. And to do that, we first have to understand that there are like hundreds of types of services available to you within Azure. And whenever you instantiate such a service, what you get in return is a resource. That can be an app service, it can be a virtual machine, it can be an IP address, a dashboard, anything. Everything is a resource. Negan would appreciate this. Now, you can interact with those resources in two ways. The first one is through the control plane. This is kind of what we're used to in the past. This was what the things that a sysadmin would do for us, or maybe even a ticketing system. Here's where we go when we need to create a new resource, a new service, or when we want it deleted, maybe when we want it scaled up or scaled down. All these things are now replaced with the Azure Resource Manager. It's a set of APIs that we call to manage our services. Next to this is the data plane. This is what we're used to interacting with. It's just reading data from a database, writing a message to a message queue, the things that our applications used to do, the interactions with the individual services. And of course, we are going to be focusing on the control plane today. Now, to recap, a number of things that a lot of cloud providers and Azure as well have is that all these resources can be grouped in logical containers. In Azure, they are called resource groups. A resource group, in turn, is embedded in a subscription. And to complete this picture, subscriptions are also here contained in management groups. So this is one way of ordering resources that you probably know. Another way of ordering those resources is by grouping them not on their logical container, but by grouping them on the resource provider that governs that resource for you. Now, a resource provider is a piece of software within Azure that you call into to create that resource or to remove that resource. The resource provider ensures that the resource is up and available, and if it's getting degraded, that it spins up a new instance and makes it available for you. In essence, it is a replacement of an operator or a sysadmin. Now, that resource provider is closely aligned with one of the teams within Azure that build those resources of that specific type. For example, there's a team that builds the app service, and they own a resource provider called Microsoft.web. Now, all of these resource providers provide HTTPS RESTful APIs that you can call to control the things that they do for you. But as there are close to 200 services in Azure, you don't want to call all these individual APIs directly. So on top of that, they created one unified API that is called the Azure Resource Manager. And this is the API that you interact with when you want to control resources in Azure. And when you start working with Azure, you do that through the portal. But actually the portal is calling ARM on your behalf. Other ways for interacting with ARM are through the Azure CLI, through PowerShell, through SDKs available for .NET, Python, Java, I think Node as well. A lot of languages now have libraries available that you can use to call directly into the Azure Resource Manager. You can also call HTTPS endpoints directly. And finally, instead of this imperative approach that all of these approaches use, you can also use a declarative approach using templates. Now, the difference is when you're working imperative, for example, from C#, and you want to make sure that a certain database exists, you first have to query ARM to see if it exists. And if it already exists, you need to ensure that it has the right capacity, the right size, the right performance, etc., etc. If it doesn't exist, you need to create it. So you have to write a big script that contains a lot of ifs and a lot of switching. And you have to make sure that you cover all the cases to ensure that you end up with the end state that you have in mind. Now, a declarative approach is completely the opposite. You do not describe the actions to take. You only describe the end result that you want to have. As a comparison, compare a programming language like C# to SQL. In SQL, you do not tell the database what to do. You only tell the database what your end results should look like. Now, the same we can do when using templates to talk to the Azure Resource Manager. Now, before we can dive into those templates, I want to revisit a few more properties of the Azure Resource Manager to help you understand how those templates work. The first thing to know is that every resource in Azure has a unique resource identifier, a URI or a URL. And that URL is management.azure.com/subscriptions, then your subscription ID, /resource groups, then the name of the resource group, /providers, then the name of the provider. So this is, for example, Microsoft.web, Microsoft.sql. So this is the resource provider. And then the specific resource type that you want to interact with. For example, a SQL server or a SQL database. To support backwards compatibility, you have to specify an API version of the resource provider that you want to interact with. And another thing that's good to know is that resources can be nested within other resources. A SQL database is on a SQL server, and that is reflected in the address of the SQL database. It is hierarchically nested under the SQL server. Now, once we have the location, or at least the location where we can manage such a resource, we can just create that resource by executing an HTTP put request against the location of a resource. So in this example, I am executing a put command against my subscription / resource group / provider / Microsoft.servicebus / namespaces / MySpace. This call creates a service bus namespace within Azure. To make that possible, I have to specify a number of mandatory properties. These are the location, which in my case is West Europe, and the SKU, which is basically how much I want to pay and how much performance I'm going to get in return. Now, once I have executed this put command, the resource provider will actually start the work to create the namespace for me. And if I now get that same URL instead of put it, I can get the actual status of the resource. So, for example, here we see that it is created. We see when it was created, when it was last updated. But also very important is that we see a link to the actual address of the service bus namespace that was created. This is the link to the data plane that I can actually use to interact with my service bus namespace. Now, interacting with Azure Resource Manager in this way is not necessarily the best way forward. You're probably going to use the portal or one of the other experiences, because this will get you dizzy quite easily. Luckily, there is a complete reference for all the things that I just touched upon. And I want to very quickly show that to you. This is the page that the link at the bottom of the slide referred to. And let's say that I want to create a SQL database this way. I search for SQL, and I really got to pick the right one. There are so many nowadays. Let's find SQL here. There we go. And then I can find all the resources that are managed by the Microsoft.sql resource provider. And one of them is, for example, servers. And on servers, there can be databases. And if I click on one of the specific versions of the API, I get an example and a description of all the properties that I can manage for that resource. And this is how, under the hood, all the resources within Azure are managed. Now, armed with that knowledge, sorry, no pun intended, let's start exploring ARM templates and their syntax and how they work. An ARM template is a JSON description of a group of resources that we want to deploy to a resource group. And this is the outer syntax for such a JSON template. The first property we have to specify is a JSON schema. And this is a mandatory property. It is a very long string that you can find on the internet. Not very important to remember. Then we have the content version. And here you can put in any versioning system you want. It's just for your benefit to keep track of which version of the template. And next up, there are four important sections: parameters, variables, resources, and outputs. Parameters are things that you want to specify at the time of deployment of the template. For example, if I make a template for a virtual machine, maybe I want to be able to put in the username of the admin account at the time of deployment. Then I make that a parameter. Next up are variables. Here I can specify key value pairs for values that I'm going to be using multiple times in the template and I do not want to repeat. Very comparable to a variable in a programming language. Then I have an array of resources. We'll dive into those in a bit. And then I can specify outputs. And they are completely the opposite of parameters. These are things that I'm going to give back to the caller of the template. For example, if I generate the name of the virtual machine within the template, I might want to return that to the caller so that he can actually connect to that virtual machine. Diving into the different parts, this is the syntax for parameters. Parameters is an object, and each parameter name has to be a key in that object. And then the specification for the parameter is another object. It has a mandatory type, which has most of the primitives that you're used to, and variations like secure string and secure object, which means that if you use those instead of just a regular string or regular object, all the values will be stripped from logs. And then there is like a minimum length and a maximum length that applies to string, min value, max value that apply to integers, default value, allowed values. And there is even a syntax for putting in comments in metadata. Variables, like I said, very simple key value pairs. Resources is an array of one or more resource declarations like this. A resource declaration has to be an object. And first you have to specify the type of the resource. And if you look very carefully at that type, you will see that the type is the name of the resource provider / the type of the resource. Then we have to specify the name of the resource. And here you can see that I do a little trick. Instead of specifying the name directly, I get that name from the variables. And this notation where you have a square bracket at the start of a string and at the end of a string puts you in like expression mode. And then we call a function called variables and we pass the name of the variable. We have to specify the API version. And if you look very closely, you see that these first three properties together make up the URL of the resource. And the remainder of the object is just all the properties that we already knew from the HTTPS calls. Now remember that we also had sub-resources. We can also specify those in a template. And to do that, we have to expand both the type and the name with one or more segments. And there is a rule here that says that the number of slashes in the name should always be one less than the number of slashes in the type. That's because the type is also prefixed with the type of the resource provider. Another thing that we can do is declare a dependency from one resource upon another. Let's say that I want to wait with the creation of my virtual machine till I am sure that my database exists, then I can declare a dependency. If I create a sub-resource, I am forced to declare a dependency. If I don't, the deployment of the template will fail with an error saying that I have to explicitly declare that dependency. The final section is that with outputs. It very much resembles the section of variables. So it's an object with a key, the name of the output. Then it has a type, but instead of allowed values, min value, etc., it just specifies the value to return. And here again, I can refer to variables, parameters, and all the other things that I generated within my template. Now, as you've already seen in some of the examples before, there are a number of functions that I can call into. Parameters and variables, I think, are self-explanatory. But for example, there is also a resource group and subscription. These I can use to retrieve some of the details of the subscription or the resource group that I'm deploying to at the time that the template is deployed. This can be very handy when you need to get the tenant ID of the subscription and put it in, I don't know, a key vault. Or when you want to get the location of a resource group and apply that to all the resources that go into the resource group. We have string manipulation like concat, but there are also things like equals, logical operators like and or and not, and many, many more. Now, just as for the templates and the URL syntax, there is a reference for those as well. So I'm not going to discuss all of them. You can look them up if you want to. And I think this is a good time to kill the slides off for a little bit and see how this works in practice. So in code, I have opened a ARM template that I want to talk you through. Like I said, the schema is a mandatory string that has to be specified. Then the version, let's make this just 3 parts. And there is an extension for code that you can use to have IntelliSense, type completion, all these pretty things when you author a template. For example, if I want to add another template, I get pretty good type completion to add things like this. And in this template, I take one parameter, and that is the environment name. It is restricted to dev, test, or prod. And what I do here is a thing that I see a lot of people do, and that I've done as well, and that I enjoy, is that instead of making all the names of the resources a input parameter, I'm only going to allow you to specify dev, test, or prod, and then I generate the names for the individual resources in the variables section. So here I'm going to create a SQL server, and the name of that server is going to be SQL Server HB-environment name. And then moving on to the resources section, you can see that I'm actually creating that SQL server here. The name is a link back to the variables. The type is Microsoft.SQL/servers. The location I infer from the resource group. The API version. Now, this thing has no dependencies. Now it's an empty array, but I can actually leave it out as well. And the remainder of the properties are resource type specific, and they follow from the reference that I guided you to before. So I'm just creating a username and a password. Don't worry, this resource will be gone directly after this presentation. And now here I do a little trick. Instead of adding more resources in the resources array, I can nest a resources array in a resource. So here I am actually creating a resource of type Microsoft.SQL/servers/firewall rules. But because I am nesting this resource, I can leave the common prefix out. And the name of this resource is actually also variable SQL server name / allow all Windows Azure IPs, but I can leave it out as well. I still have to declare the dependency relation. And then here are the properties for a firewall rule. I use the same trick to create a database, and that's basically my whole template. Now let's open up a terminal. Now here I already logged into Azure using Azure PowerShell. Basically that's a login AZ account, but you know, all the multi-factor and stuff is not very entertaining. And what I now can do is execute a command that's called new AZ resource group deployment. So new deployment to a resource group. I give the name of the resource group and the name of the template that I want to deploy. And once I execute this command, it's going to ask me for the environment name that I want to use. So let's use hoi, which is Dutch for hi. And it's going to say, hey, this is not allowed. You need to use one of these values, dev, test, or prod. So let's re-execute and say, let's go for test. Now what's happening now is that this template is sent to Azure, and ARM will compare the state of the template to my resource group. And everything that's not in there is going to be created, and everything that's already in there will be updated. And if we quickly go into that resource group, we will see that it was empty. But if I now refresh it, we will probably, no, not yet. But if I can go to deployments in the menu on the left, hopefully I can see that this deployment is now running. And when I open the details of this deployment, I can actually see one by one the resources that ARM is working on. So first it is going to create the SQL server. And only once this server is delivered, it is going to create the database and the firewall rules on that server. Now let's not wait for it because this can take a couple of minutes, but trust me, this will complete. Maybe we have time to return to this. Now, this is a very simple template that I just quickly deploy from my local computer. But there are different ways for deploying templates that might be better suited for your use cases. And to make that possible, we first have to talk about a thing called parameter files. Imagine you have a very, very big template that takes like 20 parameters. And the values differ between your test and your production environment. You do not want to type in those parameters all the time. You also don't want to manually supply them from a pipeline. Instead, you can, next to your template, create what are called parameter files. These contain all the values for the parameters, and you deploy one parameter file and your template together, and then all the values will be inserted from the parameter file. The syntax is fairly simple, a schema and a content version, and then it's an object of parameters. And instead of just key value, the value is an object with a property value. Now, that sounds a little bit cumbersome, but the reason is that instead of supplying the value directly, we can also use another syntax. This deals with a very common problem for configuration. Some parts of my configuration are secret, passwords, keys, license keys, those kind of things. Maybe my mobile phone number. Don't want recruiters to get it. Now, instead of providing the value directly, I can specify a link to a key vault and the name of a secret in that key vault. And if the person or system deploying the template has sufficient permissions to retrieve that secret, it will be inserted on the fly. It's a really neat trick. Now, once you have your parameter file and your template together, there are a number of deployment options. Azure CLI, Azure PowerShell. I think you can nowadays even upload your templates to the portal, but it kind of defeats the purpose in my opinion. But of course, if we are grown up and we put on our big boy or girl shoes, we want to deploy these pipelines or these templates from a pipeline, either using Azure DevOps or GitHub Actions, kind of depending on where you're coming from. And this is a slide that I once paid, I think like 4 years ago. So I use it on my presentations to get a maximum return for value. And what I want to do here is I want to quickly show you how I'm using ARM templates in a very simple project to create infrastructure when I need it and also throw it away when I don't need it anymore. So, but before we do that, let me prove to you that the deployment of my template succeeded. There we go. One SQL server and one SQL database. All right. Moving on to example number 2. Example number 2 is a Git repository in Azure DevOps where I have a Azure Functions project, which is the folder on the bottom. Just assume that this is a simple application, and that application needs to run on some infrastructure within Azure. And this is the template that creates that infrastructure. It takes one parameter. It's called discriminator, more or less the same as environment name. And from the discriminator, I create names for the hosting app, the function app, the storage account, all the things that I need later on. And then I create the resources in Azure that I need. These are a storage account, a service bus namespace, in that namespace a queue, on that queue an authorization rule, etc., etc., etc. Now, I think the individual JSON properties are not very interesting. You can look them up in the reference now that you know the basic build-up of an ARM template. I think what's much more interesting is what we can do with this. So remember, I have a Git repository that contains both my templates and my code. Now I have created a build definition that whenever there is a change in that repository, it compiles the C# code, it zips the outcomes, and then it publishes those binary as a pipeline artifact. And once that is done, instead of stopping, I'm going to also copy my ARM template files to staging directory and publish an artifact out of those templates. So once this build pipeline is done, it has built 2 packages, one with the ARM templates and one with the application code. Now I can use this in a release pipeline. So here we see a release pipeline definition, actually in the classic editor, because it is great for demos, in my opinion. And we see that I have 3 environments or stages defined in my release. One that is called pull request, one that is called test, and one that's called production. Now, what I've done here is I have connected this pull request environment to the build. And I say that whenever a pull request build completes, I want to directly deploy to this pull request stage. And of course, on my test environment, I have disabled this trigger. So what this means is that whenever I propose a new change in my Git repository, it will automatically compile and it start the deployment to pull request. And only when that succeeds, I can merge the changes. Once the changes are merged to master, the build will run again, and then the deployment to test will start. And if that succeeds and I give approval, it will also continue to production. Now, what I do in this pull request build or deploy is I am going to start from nothing. The first step in my pull request deployment is that I deploy the infrastructure. And if I zoom into that task in the pipeline, you can see that I'm using a connection to a subscription, but I am not specifying the actual name of a resource group in Azure. And if you don't believe me, let's very quickly go into my Azure environment, go to resource groups. And as you can see, and maybe here, there is no reference to any resource group that is called pool something. So what this will do, it will create a resource group on the fly and deploy my ARM template. Once that is done, in the next job, I use a task to retrieve the outputs of that ARM template. That ARM template returns the name of the function that it created. Then I deploy my function code. I start the code and I swap that code to be ready to be hit to what we call the production slot. Now then I wait 5 minutes because I want to give that function app some time to make sure that my code is up and just in time compiled, etc. Then I am going to stop the old production slot, now the staging slot, and I'm going to run a series of end-to-end tests against my deployed application. Now the test in this case is not very, very elaborate. I'm just going to call a specific API, and I'm going to validate that this doesn't give an error. Now, once this is done, I actually tear down my environment again. This final action will completely remove the resource group again, leaving me with no cost and having a clean environment for every time I need to validate a pull request. And as I am Dutch, you know that I probably don't want to spend more money than I need to. So what I'm going to do is I'm going to take this build definition and I'm going to make a change in the repository, trigger a pull request build so that we can see that the infrastructure starts building up, and I'm not going to monitor that. I'm just going to trust that it will be cleaned up again. So you know that I'm not lying here. So let's edit this file, commit this change, create a pull request, and open up that pull request. What we will see is that this build will start running, and in a bit we can see that this automated release will be triggered as well, that it will start creating infrastructure in a resource group in Azure that's not there yet. And we will return to that in a little bit. Now, I hope I have given you a little bit of insights in the value of ARM templates, infrastructure as code. I've given you enough pointers to get started with it, but there is so much more. First of all, the deployments that we've seen so far only target resource groups, but you can also create templates that target a subscription. So you can create resource groups in that subscription. And that makes that you can have one template that creates your resource group structure, and then you can have separate other templates that deploy to those different resource groups. So you can have a top-down breakdown. Another thing that you can do is link templates. So instead of having just one massive template, you can take one or a group of resources out, put them in a separate template, and call one template from another. Writing templates from scratch, especially when starting, can be hard. So instead, you can go into your existing Azure resources and reverse engineer a template out of those existing resources. Now, not all resources support reverse engineering. So in those cases, you can use what's called the Resource Explorer to investigate specific properties of the resources you already have. And those two I will quickly demo before we wrap up. Two other things that are interesting is a new thing that is launched, I think, just last Friday or the Friday before, and it's called Project Biceps. As you will find out when you start working with ARM templates more and more, is that they can grow quite big, and that they can be a little bit hard to maintain because it's JSON. It's not a real programming language. So what Project Biceps allows you to do is to write the templates in a JSON kind of language with a number of differences, and then compile that into an ARM template in less than a second. So it will be more concise and less repetitive, but it also allows you for very, very quick validation of your ARM templates if they are correctly written. And it's developed in the open, so you can find it on GitHub on the Microsoft Azure organization. And the final thing that might be interesting, especially if you work in a large organization, are policies. Policies allow you to also, in JSON, write a number of rules that your resources need to adhere to in Azure. And those policies are applied to every deployment just before the deployment starts. So if you try to deploy something that doesn't adhere to your policy set, the deployment will be canceled. So this is a great way to ensure that your resource groups and your subscriptions are always compliant. Not by going through them all the time and finding things that are incompliant and fixing them, but just by holding back everything that is incompliant. Now, before we wrap up, let's very quickly go back to my pull request. And what we see is that the build that is linked to this pull request has completed. And we will see that there is now a release running. And you can see that this pull request release is now running. And it is creating the infrastructure in Azure, it says. So let's just very quickly check if that's actually true. There we go. There is now a resource group pool-037 that's being created on the fly. I'm fully confident that after all the tests have successfully passed, this resource group will be removed again. And I am so because I just tested this yesterday before I made that claim, of course. Now, the final thing that I promised to show you is that I can reverse engineer a template. So let's go to my resource groups. Oh, sorry, I just have to clear the filter. Go to the resource group that we deployed to before. And then you can see that I have two resources here, my server and the database on it. And here on, you can see this option already, export template. And what this will do, it will give me the complete template that will regenerate the resources as they are. And I can use this as a starting point for writing my own ARM templates. Now, the disadvantage is that not all resources support reverse engineering already. And the other disadvantage is that all the defaults are included as well. So for example, if I look at these 4 properties, you will not find those in my template, but they are here because they are just default values. Now, if you cannot find the resource properties that you're looking for right here, instead you can find what is called the Resource Explorer. And this allows you to browse through your subscriptions or all the providers as if it were just one very, very big JSON document. And if you keep all the things in mind that we've seen today, you can really view your subscription as a big JSON document. So let's open up my resource groups, and I go again to go to my demo resource group. And what we can see here is that the different resources are listed here, and I can pick up the JSON properties here as well. Now, the advantage of this approach is that this shows a lot more of the properties and is sometimes a little bit more reliant on exporting the templates directly from the resource plate. Though I have to admit that exporting templates has really, really improved the last couple of months. That's kind of the last thing that I wanted to show you. I hope that you've seen enough to get started with ARM templates on your own. I really want to encourage you to try this at home. I'm just going to save you from the repeating animation. Here are my contact details. Feel free to reach out if you have any remaining questions. And thank you for your time. I hope you had a good time. for me, it was kind of a new experience to try and talk to my computer instead of people in front of me. But I hope you had a good time. And I think that's back to you, Florin.
Yeah, thank you so much. Welcome to the club, by the way. I think it's new for kind of everybody. I mean, yeah, but with practice, we'll get used to it. Hopefully, we will not stay in this situation for too long.
I really hope so.
Yeah, absolutely. Very insightful. Now we've got a couple of questions. The first one is related to the adoption of the infrastructure as code in, I don't know, projects, teams, companies. Have you got any insights on that?
Is the question how many teams are doing it?
Yeah, exactly. I mean, is this a thing which is understood and adopted by teams, or teams are still struggling to make the leap, the infrastructure as code approach?
I think we you have this graph, right, where everybody at some point starts adopting it. I think we are on that slope now. I think I've done a similar talk like 2 years ago, and then everybody was like, I don't know if we need this. And I think more and more teams are now practicing this already or starting to practice it. And what you see in a lot of teams is that they focus on greenfield. Because if you start with infrastructure as code and you take this approach that I take here, right? The first step in your pipeline is the infrastructure deployment, and only then you do the code, and you grow from nothing. That's really easy. But if you have to retrofit that infrastructure deployment in front of your code deployment in a deployment pipeline, that's much more difficult. And also, infrastructure as code in the same pipeline as the code often works best when the code and the infrastructure grow together. So I don't think it's only about how many or what percentage of the teams does it. I think a lot of teams do it, but not on all their projects yet. I hope that makes a bit of sense.
Yeah, absolutely, absolutely. I mean, legacy still remains a pain.
Yes.
In many cases.
We're not going to call it legacy. We're going to call it successes from the past. That sounds so much better, right?
Sounds very good. Yeah, I agree. And I think we have time for one more question, and that one was the link to the BeachApps project.
Let me be very honest, I don't have it yet because I have seen previews of it, so I didn't look into it yet, but I think if I do this...
Yeah, no worries, because I think someone already contributed with the link, so all sorted, I would say. Interestingly enough, we've got a similar topic tomorrow. I mean, a talk on infrastructure as code, but this time on Amazon.
CloudFormation.
Yeah, so it's going to be interesting to make a comparison and, understand another world, actually.
Yeah, I think there's a lot to learn in this space because we have ARM, right, which is Azure specific. And then we have CloudFormation, which is AWS specific. And then on top of that, we have all these multi-cloud initiatives. Terraform is really big nowadays, but Pulumi, for example, is one that I know that's up and coming. I think, and beyond that, we have Chef and Puppet for configuration as code. I think this space is going to become really big. I just catch the last few words of Stephen, who spoke before me, and he said that operators might need to start learning developer skills. I think that really applies to infrastructure as code as well, because this is Git, this is pull requests, this is IDAs. So I think this is kind of the same message.
Yeah, absolutely. So once again, Henry, thank you very much, and looking forward to having you yet another time at Code Camp.
I hope so. Thank you for the invitation.
Thank you. Now we're going to have a short break. It's 11 minutes, actually, and then we're going to have a conversation with Irvin. So thank you, Harry. Until next time.
See you around. Thanks.
Bye-bye.